And yeah, let's get started.
It's 10 p.m. Do you know where your children are? I don't know where mine are because I'm too busy working on pushing commit final v2 actual fix to GitHub. Unfortunately, if you're one of the 100 million plus developers who use GitHub, you may have encountered a message like this recently, or maybe all of your pull requests just disappeared completely, or maybe the search returns nothing, or your continuous integration actions just hang in the void. GitHub is easily the most important website in software engineering, but more and more developers are yelling at it, and in some cases literally crying, like it's a broken vending machine that ate their last dollar. Well, finally, yesterday, things hit the point of no return, after legendary developer Mitchell Hashimoto did the unthinkable. He packed up his open source project Ghosty and is leaving GitHub for good in search of greener pastures.
In this fall, I'm going to take my talents to South Beach.
In today's video, we'll find out what the hell happened to GitHub and why. It is April 30th, 2026, and you're watching the Code Report. In 2008, GitHub was built with Ruby on Rails as an online platform to manage your software source code with a relatively new technology called Git, which is the version control system built by Linus Torvalds in 2005 to manage the source code of Linux. The pitch was simple. Take the command line nightmare your senior engineer keeps yelling about, give it a web UI, make it like Facebook for code, and suddenly every developer on earth has a public coding profile. It worked so well that by 2018, Microsoft bought it for $7.5 billion. Today, it hosts over 420 million failed side projects and effectively is the public record of software. If it isn't on GitHub, it might as well not exist. Developers use it to store code, track bugs through issues, propose changes through pull requests, run tests and deployment through GitHub Actions, while also functioning as a social network and resume for developers, all duct taped to a Git server, which is exactly why breaking is such a problem. And the main reason developers are big mad at GitHub right now is uptime, or lack thereof. But let's check the actual receipts. According to third-party monitoring, GitHub uptime in 2025 dipped below 90%, and April 2026 is tracking around an abysmal 86%. For context, AWS S3 promises 11 nines, and GitHub is currently operating at just 1 9. However, the official GitHub status page would beg to differ and reports uptime well above 99% for all services. Regardless, the previous week on GitHub was a disaster. On April 23rd, the merge queue quietly unmerged 2,092 pull requests across 658 repos. In other words, the platform whose entire job is to not lose your code just lost your code.
And it's gone!
Then on April 27th, GitHub's Elasticsearch subsystem was hit by a botnet that took down GitHub Search for hours. And then on April 28th, GitHub was forced to publish 2 blog posts the same morning. One was the CTO apologizing for reliability, while the other was about a critical remote code execution vulnerability, where Git push could literally execute code on GitHub servers. A few big projects like Zig have already migrated away from GitHub, but then shit really hit the fan when Mitchell Hashimoto dropped this blog post. He's the creator of tools like Vagrant and Terraform, which are part of his company HashiCorp, which was taken public and made him extremely rich. Despite having enough money to own his own private jet, he still bangs out code daily building a terminal emulator called Ghosty. He joined GitHub in 2008 as user number 1299 and has logged in almost every single day for 18 years. But on April 28th, he wrote a breakup letter while literally crying. Speaking of GitHub, he said, quote, "I want to ship software, and it doesn't want me to ship software." That line hits hard, and he says he kept a journal for a month and put an X next to every day a GitHub outage blocked his work, and almost every day got an X. At this point, he's had enough, and his 50,000 star GitHub project Ghosty is leaving the platform for good. That's a massive vibe shift, but who can we get blamed for this? Well, it's easy to point the finger at Microsoft because it's literally their sole responsibility to make this website work, but I actually know people who work at GitHub and believe they're trying.
The key to success is developers, 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 developers. Developers.
When they acquired GitHub back in 2018, it actually got better in the years that followed, with features like actions, code spaces, etc. But now, in the AI coding era, the enshittification is real. A GitHub CTO admits, in writing, that since 2025, agentic development workflows have accelerated sharply, which translated into English means that AI agents are hammering GitHub like it's a free buffet. GitHub isn't just a host for developers anymore, it's a host for their replacements. In the same way Bill Gates saved the world from COVID-19, I have faith Microsoft will turn the GitHub ship around. But if they don't, there are alternatives out there. You've got the reliable but boring GitLab, you've got the German nonprofit Codeberg, and you've got the minimal SourceHut, which has zero AI features whatsoever, and many other viable platforms ready to reap the benefits of GitHub's downfall. That means the good news is that if you make the mistake of choosing to become a programmer as a career, there will always be a home for your code. But did you realize you have 80,000 hours in your career, 40 hours per week, 50 weeks per year for 40 years? That's a lot of time to make a positive impact on the world. And 80,000 hours, the sponsor of today's video, can help you do that. If you're young, you've probably heard advice like follow your passion, do what you love, and take the initiative. But these cliches are not based on evidence or data, unlike the work of 80,000 Hours, which is a nonprofit that for the last 10 years has been researching the question of how do you find a fulfilling career that does good too. Their website has tons of collected research on high impact careers, along with job boards, podcasts, and a lot more. It's an incredible resource for anyone looking to start a high-impact career or make a switch mid-career. Join the newsletter today to get a free copy of their in-depth career guide sent to your inbox. It could be the catalyst that changes your direction in life. This has been the Code Report. Thanks for watching, and I will see you in the next one.
Okay, now let's get started. Let me share my screen. Okay, so we're continuing off with Project 10, which is the Pong game. So we did the Pong game class. So this is pretty much finished. And the Q-learning agent for the AI brain.py. This class is also finished. So last week we finished off with Play vs. AI, the versus game class. I'm pretty sure we did everything up to the main, so we'll do this today. And then we'll finish it off with main.py. And then we'll start off with Project 11. So yeah, let me share the GitHub. Here's the GitHub. Here's the live share. And let's start off with Adam again. Adam, when you're ready, please share your screen. And yeah, let's get started. And after Adam, we'll do Albert next. So Albert, just get ready.
The site's blocked.
The site's blocked for GitHub?
Yes. By my computer.
Okay, I don't know. Maybe can you try the live share?
No, I mean the live share is blocked.
Oh, the live share is blocked. Try again. I think it's because I have to accept you.
No, it says that I have to ask my parents.
Oh, okay. But let's just do the GitHub. So open the GitHub link and then download play versus AI.py. Yeah, I guess you have like parental permission stuff. But yeah, while you do that, Adam, Albert, can you share your screen first? And actually, Albert will probably do the play versus AI. So Adam, just get ready with the main.py.
Oh, I'm ready. I'm
Oh,
ready.
okay. Albert, can you stop sharing and then we'll just do Adam first because Adam has that one file. And then you can share your screen now. Okay. Okay. We can do Notepad. Okay. So if you see down, you see the define main function. That's what we're gonna do. So basically you're gonna create so you're basically just doing calling all the functions that we made. So if you go down, we're just gonna call the agent, create one, and then load in the model file that we created, and then initialize the class versus game and the clock, and then just start the game loop. So do backspace. Yeah, right there. And then do agent equals capital Q, capital L, Q learning, capital A agent, Q learning agent. Yep. And that's a class. So you want to instantiate it. Yep. That's good. Yep. Next line. It'll be four spaces. Agent dot load model. Agent dot load underscore model. Function. And we're going to pass in the name of the file, which is string. So the quotation. Yep. And it's going to be Pong underscore AI dot pkl dot pkl. So this is the pickle file. So it's a model of the Q learning agent that we trained. Next line, game equals, and we're going to instantiate the versus game. So capital V versus capital G game. That's a class. You're going to instantiate it. Yep. Next line, clock equals pygame dot time dot clock. Clock is capital C. And that's a function. Next line, you're going to do while true, and it's a capital T. Enter. Yep. You're going to do human underscore action equals none with a capital N. Next line, uh, for event in event in pygame dot event dot get function, colon. Next line, if one, two, inside the for loop. If event dot type event. Equals pygame dot all caps quit colon in the same line return. Or you can do it there. Return. Yep, that one works. Enter in the same line as for keys equals keys, like key and lock, equals pygame dot key dot get underscore pressed. And that's a function. Pressed ed. Function, next line, and you can stop there. Sure see. Okay. So basically, what we did here. So we basically set the agent to an instance of the class. You guys have done this a lot, right? It just basically makes makes an instance of this Q-learning agent. And then you're making this agent load a model, which is the AI that we trained. And then we make an instance of the game. And then we set the game clock. This is the game loop. While it is true, we want to do human action equals none at first. And then for each event, then we want to say if the event is quit or like the player exits out, then we want to exit out of it. So we return. Then we get what the user or this human action pressed. So if I press like pop or like up arrow, down arrow, actually I think it's WS. Yeah, WS. So if we press W, then it's a up. If we press S, then it's a down. And then we want to get the game state and the AI action. And then for each AI action and the human action at each every like second, then we say, okay, we're gonna do this step. And if you guys hover on it, click on it, then there will be play step function, which is part of game, and game is an instance of versus game. So if you find out where this is, play step is basically a function of versus game. So let's hover on it. You guys can see the class is versus game. We have the play step function. Where were we? Yep, and then we render the game and then set the clock tick. Make sense? And basically how this works, I mean, looks like this is what we created, right? Play versus AI. Here's the solution one. So let's just try it. I did not share the whole screen. Basically, this is it, right? It's you versus the AI. If I move it up, W, then it hits, move it down, etc., right? But yeah, that's the play versus AI. And then we'll do Albert, and you'll do the main.py. And And then after Albert, Hayden, you'll go next. And Albert, the main.py, the main function is really large, so we'll do like half of that around. Okay. Okay. It's great that you're using Git, and I saw you do Git stash as well, so you know your Git as well. That's good. And you have a virtual environment. Okay. Do you have your pub key and your private key there? Okay. No, don't show it. Don't show it. Yeah. Basically, those are secrets, and you don't want to show anyone else. Well, you can show people the pub key, but you can't show the private key to anyone, or else they can access whatever you use that for. But it's probably not an issue though. Anyways, main.py, basically you want to create a game environment, and then you start the loop, and you train, it says 2000 episodes, you guys can do whatever, and we'll start the game, and we'll make it train, and we'll save it as a model so that we can reuse it for the playverse AI. That's basically what this does. So you delete the pass. Let's go backwards. One backspace. Yep. So we'll do game equals Pong game, and we'll set visual equals false. So basically, we're instantiating the Pong game as game, and we're instantiating the Q-learning agent as agent. Next, we'll set epsilon to 1.0 and best streak to 0. So why is this epsilon? Remember, is kind of the percent chance that you'll make a random move. Why is it 1? Because at the start you want to make a random move because you don't have any memory, right? You don't want to rely on something we learned before because we don't have anything. That's why it's 1. So it's 100% chance of choosing a random move. Now best streak, basically set it to 0 at first. Enter. You can print something, but yeah, no need for that. So do 4 epsilon in range. You could do 2000. Let's do 1. So range of 1 and 2001. Yep. And let's see. State equals game dot reset. So we want to reset the game and set it to the current state because that's what the current state is. And then you're doing done equals false so that you can loop over it later. And the current streak is 0. So while it's not done, so while you're not done, you want to just keep looping through the same actions, right? Which is action equals agent.choose action. So you're relying on what the current state is, how much epsilon is, and basically you do choose action, which depending on what the epsilon is, chooses a random action or the best action based on what we learned. Next is next state, comma, reward, comma, done equals game.step. Basically what we do here is make that action, which was chosen in choose action. So we make it, we found out what the reward is if the game ended, which is done, and we get back the next state. And then we do game agent.learn, basically this where we pass in the action, the reward, etc. State equals next state because in the next game loop of while not done, you want to set the current state to the whatever state is now after we do the action. And if reward is greater than 0, greater than 0, then we want to add to the current streak. If episode is like every tens, then you want to render a new game saying like updating the score and whatnot. If the current streak is better than the best streak, then you want to replace it. Everything else is fine, right? You just multiply it by that constant and you check if it is 0. And yeah. Let me know if you guys have any questions. I don't think you guys do. Uh, You can stop sharing now. Kaden, can you start sharing? And Charlie will go next. Go to just pass. Delete it. Backwards one more. So we'll just continue off with where he was. I think you need a tab. Do you need a tab? No, you don't. Okay. So do print, or actually just do agent. Oh, you need a tab. Agent dot save underscore model. And we pass in the Pong underscore AI dot PKL. Dot PKL. Yeah. Next line, you want to do well, true, and true is capital T. Then you want to do state equals game dot reset. And that's the function. And then you want to do next line, done equals false. Enter. Score equals 0. Next line. Well, not done. Then you want to do action equals agent dot choose action. And you pass in state and epsilon equals 0. Next line, you want to do state, comma, reward, comma, done. Equals game dot step, and we pass in action. Next line, if reward equals 10, then you want to do score plus equals 1. Backspace, game dot render, and you pass in. So mode equals showcase. Okay, let's do this. Delete the mode equals showcase. In the line above, create a new line, backspace. Do args for ARGS equals a dictionary, which is the curly bracket. And you're going to do mode, so string mode, which is the key, colon, and showcase is going to be a string, and that's going to be the value. Yep, like that. So that's the first pair. Second pair is going to be score equals score, string score, score, and then comma. Next one is going to be best colon best score or best streak. So it's going to be capital B best colon best streak. Yeah, but it's going to be just best. No, no, not that, not that. The key. Sorry, the key is going to be just best, not streak. Yeah, and then score is going to be capital S for the key. Yeah, and then mode is going to be all caps. Yeah, thank you. And then render, and then render function, and you pass in the args. Yeah, and then the next line, high game.time.wait, 15. Oh, wait instead of week. Yep. And yeah, that's good. You can stop sharing. So now we're basically done. So we built the main, which basically instantiates our classes, trains for 2000 episodes, saves the model, and once the training is complete, we can watch the AI play. So if you run it, oh wait, that's the wrong one. So you can see a training, 100 episodes, 180 episodes, 190 episodes. You can see the current hits. You can see the best streak. You can see the exploration constant. You can see the memory size. So if we let it run, it'll go to 2000 episodes. Uh, okay. Less than 20 already. Okay. 1,000 episodes. Okay. Okay, I don't think it runs when I'm exiting out of the. Let's just wait a bit more. And you guys can see this is why you probably need a GPU for massive computations. I mean, we're only doing what, 2,000 episodes, and it's taking at least 3 minutes. One time I was training a AI model for ESP32, so firmware, and it was taking too long on the Mac, and the training didn't complete. So I had to go up to SFU to train on the GPU. So yeah, okay, 1,500. But yeah, you guys can try this on your own after as well. Once I release the solutions, you guys can try playing around with the episodes and the exploration, etc. If you guys do that, make sure to set up your virtual environment like Albert did. You're going to want to install all the dependencies. You guys will probably get like dependency errors like not found Ktinker or something. You guys are going to want to install that inside your virtual environment. And yeah. Okay, only 100 more. But do know this will not be perfect, guys. You guys can see it's still losing like sometimes. So this is after training. This is only after 2,000 episodes. And this is how the AI is moving. You guys can see my hands up here, right? So it's basically only relying on what it trained on. And you guys will see the AI, the UI is kind of weird. It's only because we didn't care too much about the UI. But yeah, it's not perfect, but it's better than just a solid pedal that stays in one place, right? This will get better with adding more parameters, more training data, more episodes, etc., right? But yeah, this is it for this. In terms of next steps for this project, I would just suggest, okay, either you guys can emulate it or make a website that shows this Pong game as a UI, or you guys can make this AI stronger and win more times and get a better streak by learning some more or tweaking some of the parameters, as I said. And yeah, if there's no questions about this, we'll just get started on the next one. Um, uh, where is the code? Okay, Project 11. What is the unit? What unit is the memory size measured in? So the memory size is not memory size. In this case, it's the Q table dictionary. So how many entries are in the Q table? So it's not really memory. It's in the, it's a memory in the case of the AI. So it's how much is in the Q table, the dictionary. Make sense? Anyways, okay, Project 11. This one's gonna be short. Why is it erroring again? Okay, let me actually install the dependencies. So this is how you guys install dependencies when you guys have your virtual environment. So do pip install pandas sklearn gradio and okay, what is it? Oh, scikit-learn, and it should be downloading like this. Anyways, for this one, it's going to be really short, just one file. Basically, you're going to create this mini data set. You're going to load the data. You're going to split it, vectorize it. You're going to train the AI, test it, and make a prediction. And yeah, so if we launch it, Project 11 main.py. Why isn't it launching? Okay, there it is. Let me show you guys. Okay, if I run it. So this is basically making a visual web interface, so like a website or whatever. As you can see, it's doing all the training. Model accuracy is 50% because our data set is really only this. So if you guys add more data, it'll be faster and better. Anyways, running on this endpoint. So how you guys read endpoints, HTTP is the protocol. This is not secure because there's no S. So if there's HTTPS, then that's the secure version. So all messages are encrypted. This one is not, it's no encryption, no nothing. 127.0.0.1 is the IP address. So IPv4, but 127.0.0.1 is a special type where it's only my local MAC. So only my local MAC can access this. And then we have the endpoint, which is 7860, which is the port. Basically 80, port 80 is What is port 80? I think it's SSH or something. Anyways, something like that. But basically, if I type a review, I don't know, let's just do this. Submit. Okay, that one's wrong. Basically, we're trying to do some sentiment analysis, but you guys can see it's really bad because it's 50% accuracy, but we can add more if we want and see if it works better. And we'll get started. Oh yeah. For this one, I'm gonna make you guys make the functions as well. So anyways, let's get Charlie. Can you share your screen? Yes, Charlie. 1 second. Accepted it. May not PY yet. So for this one, why it's short and why there's nothing but comments except for the create mini dataset. I wanted you guys to basically do everything from scratch. So basically doing everything from scratch except for that create mini dataset. So you guys will see how you guys import while you guys do like code. So let's go to step one. Actually, 1 sec. Project 11. Yeah, okay. So step one, just go X on the extension Python. So you'll see the tab, right? Yeah, that one. Basically that's something called an extension. It's a VS Code extension. You guys don't need it on this, but if you guys want, you guys can have it on the VS Code on your local laptop. Anyways, load the data. So you want to read the CSV, which is an Excel sheet for those that don't know, and you guys want to return the loaded data from. So you want to do backspace because you're starting from nothing, right? Now you're going to want to create a function called load dataset. I mean, load data. Yep. You're passing in one argument. It's going to be file path. Good job. And then remember to close it off with a colon. Yep. Now you're going to do df equals, and you're going to want to use the pandas, but you don't have pandas right now. So go all the way to the top where the imports are. You're going to do import pandas as PD. PD is a common acronym for pandas that people use. So do PD dot read underscore CSV. This one you pass in so hover on it, and you'll see that you want to pass in a file path or buffer. File path is whatever we set the argument as, right? And then you want to return that, return df. Yeah, let's do split and vectorize as well. So delete the pass. So basically in this, you want to extract it and extract the review and the sentiment, and then you want to split the features. You want to create a new object and yeah, vectorize everything. Yeah. So basically backspace, backspace. Yep. Now you want to define a new function, and it's going to be called split and vectorize. And yeah, and is usually better. The reason you don't do and like that is, well, for Python you can do it, but in C and C++ or other languages, it might mean something else. Where in C and C++ is used a lot for accessing the memory location of yeah, of a data, so setting it to a pointer location. Anyways, split and vectorize, you want to pass in df, and that's yeah, and then do x equals df. Yep, that was good. And then you want to do the key is review, string review. Same thing, but y equals df and then the sentiment. Yeah, good job. Next, x train, comma, x test, comma, y train, comma, y test equals train underscore test underscore split. And that's a function. And the function is arguments are x, comma, y, comma, test size equals 0.2, comma, random state equals 42. For D2, yeah, good job. Vectorizer, next line. Vectorizer equals capital C count, capital V vectorizer. Yeah, exactly like that. Reason it's like that is because it's the class. And yeah, good job. Next line. You want to do x train vec as an x train vector, or up to you actually. Equals vectorizer dot fit transform fit underscore transform, and you pass in x train. Next line, same thing, but x test vec. That was a good idea though. Yeah. Test vec. Test vec equals vectorizer dot transform x test. Great job. Next line, return x train vec, x test vec. So both. Yep. Comma y train, comma y test. Comma vectorizer. Good job, Charlie. You can stop sharing. James, are you able to share your screen? Can you skip me? Yes, that's all right. And Jordan, can you share your screen? Yep, no worries. If Jordan can't, Liam, can you share a screen? Thank you, Liam. And you'll do some easy ones. Step 4, which is train AI. So backspace. Basically, you're gonna train the AI. I mean, it's just gonna be really quick. Train underscore AI. And that's a function. You wanna arguments, right? Arguments are gonna be X train vectorized. X train vectorized is one word. So just do yeah, underscore. Vectorized. Yeah, good job. Comma Y train. Oh, one more argument. Great job. Next line. Model equals. So this one's gonna be a class. Capital M, multinomial. So N-O-M-I-A-L. Yeah. And capital N, capital B. And that's a class. One thing though, nomial, they're all lowercase. N and the M. And the circle bracket for class. Next line, model dot fit. That's a function. We're gonna pass in our argument X train vectorized and Y train. One thing there, vec has to be vectorized because we changed the name for the scope. Yeah, good job. Return the model now. Uh, okay, go all the way up. The reason why multinomial and count vectorizer is not there is because we need to import it. So after the pandas as PD, do from sklearn dot model selection space import train underscore test split. Yeah. Next line from sklearn dot feature extraction dot text space import count vectorizer. Great job. Next line from sklearn dot naive Bayes. So NAI. Yep, that one. Naive Bayes. Naive underscore BAYES. Yeah. Import multinomial NB. Naive Bayes is a form of another type of AI training model. It's hard to explain now. Okay, right after this, I'll show you guys a video. And then, actually, you can stop sharing now. Let me find the video for you guys. Alright, can you approve me? Yes. Now, James, can you share your screen and then I'll show you guys the video. James, I approved you. Can you share your screen? And we will do test. So do step 5, test the AI. So you're gonna use the train model to predict the sentiments and calculate the accuracy score and return it. So backspace, you're gonna create the function. So do the DEF as defined, calculate accuracy, and the arguments, there's gonna be 3 arguments: model, comma, X test vectorized, comma, Y underscore test. Next line. One thing, colon. Yeah, good job. Predictions equals model dot predict. Model is on a lowercase. Model dot predict. Oh yeah, that's because yeah. Predict function X test vectorized is the argument. Next line, accuracy equals accuracy score. Underscore score. And that's a function, and we pass in Y test and predictions. And we return accuracy. Now go all the way to the top. Right after pandas as PD. Next line. You're gonna do from sklearn sk dot metrics import accuracy score. And that's it. You can stop sharing. And let's watch a quick video on knife bays.
Welcome to AI Explored. In this video, we will explore the fundamental concepts behind naive Bayes, including Bayes' theorem, probability and conditional probability, and how they all come together to form the naive Bayes algorithm. We will also take a look at the different types of naive Bayes classifiers and their unique features, as well as the various applications in real-world scenarios. By the end of this video, you'll have a solid understanding of naive Bayes and its practical uses in the world of data science. Bayes' theorem comes from 18th century mathematician Thomas Bayes, who proposed that the conditional probability of an event, based on the occurrence of another event, is equal to the likelihood of the second event given the first event multiplied by the probability of the first event. The development of naive Bayes as a machine learning algorithm was greatly influenced by this theorem and was key in the development of the modern naive Bayes. To fully understand naive Bayes, it's essential to have a solid understanding of probability and conditional probability. Probability is the likelihood of an event occurring and is represented by a number between 0 and 1. Conditional probability is the probability of an event occurring given that another event has already occurred. It is represented by P I/B, which means the probability of event I given that event B has occurred. Naive Bayes relies on the assumption that the variables are conditionally independent, which means that the occurrence of one feature does not affect the probability of another feature occurring. The algorithm is a simple and effective probabilistic classification algorithm that is based on Bayes' theorem. The algorithm assumes that the features or attributes of the data are conditionally independent of each other given the class, which is where the naive in naive Bayes comes from. This means that the algorithm assumes that the presence or absence of one feature has no effect on the presence or absence of another feature. The algorithm works by calculating the probability of each class, given the observed features of a data point, and selecting the class with the highest probability as the predicted class. This is done by multiplying the prior probability of the class with the conditional probability of each feature given the class, and then normalizing the result to obtain a probability distribution over all classes. Despite its simplicity and the naive assumption it makes, naive Bayes can perform surprisingly well on a wide range of classification tasks and is often used as a baseline algorithm for comparison with more complex models. There are several types of naive Bayes algorithms, each suited for different types of data and classification tasks. The first
I think that's all we need to know. Basically, I use this probability. There's two types. One's the probability itself of something happening. One's the conditional probability, so something happening based on something else. So let's say like, what's the probability of what's the probability of raining tomorrow, given that today it was sunny? Basically, something like that. Mm. But yeah, basically that's it. And then next, James went, Liam went. So let's just go back to the top. Adam, can you share your screen? Let's just do one more and then we can call it. Actually, two more. So what we'll do is make a prediction. So, right. Um, okay, you know what? You can stop sharing your screen. Albert, can you share your screen? This one will be quick, no worries. Go to project 11 and main.py and go back down to step 6, make a prediction. Yep, delete the pass, and basically all you need to do is place the input into a list, transform the text list into numbers, and use the trained AI to make a prediction. So basically, you want to define, because it's a new function, so do backwards, uh, delete, like, enter, delete, yeah. DEF, so define, predict, review. Yeah, you're passing in the text, model, and the vectorizer. And you want to do text underscore list equals list equals list of text. Next line is going to be text vectorize equals, yeah, vectorizer.transform text list. Prediction equals model.predict text vectorized, and yeah, you pick the first prediction. You can stop sharing your screen. Next, Caden, if you can share your screen, and you'll just make the main application. No worries. You can take your time. Go all the way down to main application execution. Go down then. It's gonna be the last one. Yep. Up a bit. Up a bit more. Yeah, right there. Line 80. 80. Yep. You're gonna do if main equal, if underscore underscore name equals, that's good. Equals, string underscore underscore main. Yeah, good job. And then enter next line. Create underscore mini underscore dataset. Also, Dan, your computer is laggy. Create mini dataset. That's a function. And then let's jump to line 87. df equals load data, and we pass in movie review.csv. And then go down to 91. You're gonna do x train vec, comma, x test vec. So it's gonna be x train vec. So x underscore train underscore vec. And x underscore test underscore vec. And then y train, y test, and vectorizer. Equals split vec and vectorize, and we pass in df. Vectorizer. Split and vectorize. Yep. 94. You're gonna call the train AI function. So trained underscore model equals train underscore AI function, and we pass in x train vec and y train. Not vec. And 97, evaluating model, you want to do accuracy equals calculate accuracy. And it's a function, you want to pass in trained model, comma, x test vec, comma, y test. And yep, go down to 102, enter. You're gonna define a new function inside this function, so do def space gradio gradio underscore predict, and you're gonna pass in the user text. You're gonna do return predict review user text train model vectorizer predict review. Predict review function. So predict underscore review. You're gonna do text trained model vectorizer. Next line, interface equals gr dot interface. I think you have a R there that's not supposed to. Yeah. That's a function, and we pass in fn equals gradio underscore predict. Comma input equals gr dot textbox. And the label, I mean the lines equals 3. Comma lines is lowercase l. Comma placeholder equals string type of movie review here. Next line, outputs equals gr dot textbox. Label is AI sentiment prediction. It's a string. Next line, title equals live sentiment meter. Next line, interface dot launch. And that's a function. You can stop sharing. And let's just finish off with a quick look at. Actually, let me stop recording.